Here's a list of the top 10 lesser-known but powerful space rocket and spacecraft technologies that most people never hear about. A rocket engine works by burning fuel to create hot gases and then pushing those gases out through a nozzle to produce thrust. This thrust propels the rocket forward following Newton's third law of motion. For every action, there is an equal and opposite reaction. Basic steps of how a rocket engine works. 1. Fuel plus oxidizer, combustion. In space, there's no air, so rockets carry both fuel and oxidizer. These are mixed and burned in a combustion chamber. This produces very hot, high-pressure gases. 2. High-pressure gas, nozzle. The gases rush out through a narrow nozzle at the back. The nozzle speeds up the gases and directs them to produce maximum thrust. 3. Thrust pushes rocket forward. As the hot gas exits backward, the rocket moves forward. Types of rocket engines. 1. Chemical rockets, most common. Familiarity. Use chemical reactions between fuel and oxidizer. Example, SpaceX Falcon 9, NASA's SLS. 2. Solid fuel rockets. Fuel and oxidizer are mixed into a solid block. Once ignited, they burn until exhausted. Syracuse, but not controllable. 3. Liquid fuel rockets. Fuel and oxidizer are stored separately as liquids. They're pumped into the combustion chamber. More complex but controllable and restartable. 4. Ion or electric thrusters. Used in satellites. Use electricity to ionize gas and eject ions at high speed. Very efficient but low thrust. Great for long missions. Real example, how Falcon 9's Merlin engine works. Fuel, RP1, refined kerosene. Oxidizer, liquid oxygen, LOX, mixed and burned in a combustion chamber. Gases expand and shoot out through the nozzle. Thrust lifts the rocket. Top 10 space rocket spacecraft technologies most people don't know. Ablative heat shields used by Apollo, Soyuz, SpaceX, Dragon. What it does, absorbs and burns away during re-entry to dissipate heat. Why it matters. Without this, astronauts would burn up during Earth return. Reaction Control System, RCS, used by all maneuverable spacecraft. What it does, uses small thrusters to control orientation, pitch, yaw, roll. Why it matters, essential for docking, pointing antennas, or landing accurately. Ion propulsion, electric engines, used by NASA's Dawn, Bepi Colombo, Deep Space One. What it does, accelerates ions using electricity, providing ultra-efficient thrust. Why it matters, allows spacecraft to travel billions of kilometers using just kilograms of fuel. 4. Magnetorquers, torque rods, used by small satellites and space stations. What it does, interacts with Earth's magnetic field to change orientation. No fuel needed. Why it matters, saves propellant on long-term missions. 5. Whipple shield, micrometeoroid armor, used by ISS, satellites, Hubble. What it does, a layered shield that absorbs hyperspeed debris impact. Why it matters, protects spacecraft from particles moving at 10+ kilometers per second. 6. Sunshade technology, like on James Webb Telescope, used by James Webb Space Telescope. What it does, reflects solar heat using multi-layer films, keeping instruments cold. Why it matters, enables seeing faint galaxies by blocking IR heat from the sun. 7. Loop heat pipes, space cooling systems, used by satellites, ISS. What it does, moves heat away from electronics without fans or moving parts. Why it matters, keeps equipment functional in extreme temperatures. 8. Grid fins, reusable rocket steering, used by SpaceX Falcon 9, Falcon Heavy. What it does, aerodynamic fins steer the rocket stage back to Earth. Why it matters, makes booster reuse possible, cuts launch cost by 90%. 9. Deployable booms and antennas, used by Voyager Mars orbiters. What it does, unfolds delicate instruments or solar arrays after launch. Why it matters, lets spacecraft launch compact, then deploy massive systems in space. 10. Cryogenic fuel management systems, used by Artemis Starship Delta IV. What it does, keeps supercold fuel like liquid hydrogen stable for long durations. Why it matters, enables deep space missions and in-orbit refueling. Bonus, you might also like electrodynamic tethered Lasers generate power or thrust using Earth's magnetic field. Laser communication, optical comms, faster data transmission from space. Star trackers, celestial navigation using stars like GPS.